All right. So I want to talk about climate change and what we know and what we don't know. But before I do, I just want to remind you of what you've heard this morning, that science marches in a very erratic way. Begin with observations, maybe conjectures, followed by experiments, sometimes theory, and it goes back and forth. And there's a few empirical observations. I'll give you an example of how this works. As a physicist, I go to the government, and I'm there for 430 years. And in the very first cabinet meeting, I say to the president, Mr. President, in bureaucracies, everything comes to a halt unless continually pushed. In fact, Newton was wrong. Archimedes was right. Everything is governed by friction. Another empirical law, the first law of politics, get elected. There are three laws. Second law of politics, get reelected. Third law, when in doubt, consult rules number 1 and 2. All right. So as one gets information, you might reject the information. And because of that, antibodies come out. And we discussed why that is so. If it conflicts with your held beliefs, strongly held beliefs, that's what happens. So what are the tactics that are used? And in the United States, we call this FUD, for fear, uncertainty, and doubt. And what you do is you spread fear that this knowledge might lead to a government regulation, and that regulation might actually conflict with your worldview, the way you make a living, and so you begin to reject it. And you actually have you muddy the waters by spreading uncertainty. So if science says this, you find someone else that might say something different, ideally a scientist, but if not, a pseudoscientist, it doesn't matter. If the ratio is 5,000 to 1, that doesn't really matter. The press is happy to interview that 1 in 5,000. And then you use fear and uncertainty to turn what would be healthy skepticism into denial. Okay, so here's some information. This is the land and water temperatures around the world, averaged around the world. The first question is, are these measurements accurate? Was there bias in the measurements? Maybe you make more measurements around cities, which then actually tend to raise the temperature, so on and so forth. But this has been worked out over many, many years, 20 plus years of challenges, reassessments. I just want to remind you that this is a recent phenomena. We talk about the beginning of the Industrial Revolution, but most of this rise has been since 1976. Now let's talk about climate change. This is some change in climate, but if you look back at the history, and there are three graphs. The bottom graph is the temperature where the extreme right-hand side is the present time and going backward 800,000 years. And look, the climate is changing. We are in a warm, stable period, but before that there was an ice age. There was another warm, stable period, only about 1 to 1.2 degrees warmer than we are today. Ice ages, ice ages, ice ages. Neanderthals roamed the earth at this period of time. Homo sapiens came at this period of time. And I can assure you, based on a strong faith, that Neanderthals weren't responsible for climate change. But you see the other thing, methane, carbon dioxide. There was no industrial revolution. There was no massive human emission of carbon dioxide. And you notice that they're strongly correlated. So you can say, well, the climate's changing. Carbon dioxide cycles with temperature. So this is a natural phenomenon. Well, is it? By the way, that's where we are in carbon dioxide and methane. So we're going off the charts. So this is the more recent past in the last 10,000 years. And then all of a sudden, the change looks a little bit funnier. There's a long, stable period, and all of a sudden, carbon dioxide seems to shoot up. And we're right now over here. And you look at the time scale over the last 10,000 years, and you find out 3/4 of the increase in carbon dioxide has occurred over the last 65 years. But it's more worrisome than that. The rise in carbon dioxide actually matches what we estimate was being emitted by human activity. And Not all the carbon dioxide is up there. In fact, 45% gets very quickly absorbed by plants in the ocean. And so we also understand that. So if you believe in accounting, this is very consistent. However, there's much more compelling evidence that this is not a natural cycle. And this is very important and seldom discussed in the press. And it has to do with carbon-14. Now, listen to me for a moment. Don't look at the pictures. Let me tell you how carbon-14 is made. It's made in the upper atmosphere, cosmic rays. Protons bombard nitrogen and turn into carbon-14. You all know that carbon-14 is radioactive. That's what we use for radioactive dating. This carbon-14 diffuses down in the upper atmosphere into the biosphere. You and I have carbon-14 in ourselves, and there's some mixture of carbon-14 in us. We have mostly carbon-12, but a small fraction of carbon-14. Now, you go, you're buried, you die, you're buried. Hopefully you die first, you're buried second. But, and they put you in a really good coffin, completely separated from the rest of the earth. And 5,700 years, only half the carbon-14 is left. Another 5,700 years, another half is left. Another quarter is left. And you go on and go on and go on. After 100,000 years, guess what? No more carbon-14 in you. Then they exhume you, put you in a power plant, you and your friends, and generate electricity. Now, if there's enough of you and your friends generating electricity that goes up in the atmosphere, there's less carbon-14. Okay? So, is there a big enough effect? Now we look at, on the blue line and the red line, the increase in CO2. We look, I'm only going to talk about the green line. We look at this, and the ratio of carbon-14 to carbon-12 is going down. But you say, wait, you're stopping the data in 1950. What is going on? Well, it goes a little off scale. The carbon-14 zooms through the roof. Why? Because the United States and the Soviet Union started testing H-bombs in the atmosphere. That makes a lot of carbon-14. And you see it was in the northern hemisphere, followed by the southern hemisphere. The oceans began to pick up the carbon-14, first in the northern hemisphere, then in the southern hemisphere. Everything's being diluted. It's going down, going down, going down. But how is it going down now in the recent past? It turns out the dilution of carbon-14 is also consistent with how much fossil fuel we're burning. At the very least, the dilution of carbon-14 means it had to be isolated from the environment for many lifetimes. Trees don't do that. They live, they die, they get recycled by microbes. Much of the ocean doesn't do that. So this has convinced most scientists, and then carbon-14 in the ice cores also convinced most scientists, this is unlike any other change. This is different. All right. So there's a claim there are warmer periods, and now I can speak about how the opposition creates the uncertainty. And they say, well, we've just come out of an ice age, and they actually take scientific data, legitimate scientific data, and they say this is from an ice core, the same ice core that we use to measure climate change, one ice core in Greenland. And look at this. They say, you talk about unprecedented warming. The headline was, Greenland ice core analysis reveals multiple periods prior to the 20th century where there's unprecedented warming. And you see the warming, Bronze Age, Iron Age warming, the Little Ice Age in the medieval times, cooling. And they say, look, we're just coming back to average. This is nonsense, okay? So what's going on? Well, it's data selection. If you look at all the data of all the ice cores and you bring it up to date, you find, I'm sorry, we're out of that now. Okay, when the new data appeared, it was invisible on the conservative blogs. Not only that, you pick the data that most reveals what you want to do. And so when scientists select data, they're going into very, very dangerous territory. You just don't do that. So let me talk a little bit about, 5 minutes. When I was in Washington, much was said about that little plateau between 2001 and 2013 where there was a leveling of temperature. Why was there such a big deal there? because the climate models predicted that the temperature would increase. And over this 10 or 12-year period, didn't increase. So the reaction is, you guys don't know what you're talking about. This is crazy. And they didn't talk about the earlier time, but just, over the last 10 years. So what was going on? Why did the climate models miss that plateau? And so it was suspected that perhaps the heat went into the ocean, but you don't conjecture that. You go out and measure it. And so what scientists did is they dropped these yellow buoys. That's the thing in yellow, not the person in white. And they dropped them all around the ocean. And they go and they report the temperature of the surface. They go down 2 kilometers. They're measuring temperature and salinity as they go down. They measure as they come up. They radio information back. They last for about 4 or 5 years. The battery runs out. You say, well, this is not going to really tell you what's happening in the oceans because, what are a few buoys? The ocean's very big. And you'd be absolutely right. You drop a lot of them. Different colors are for different countries. The whole scientific community was taking part in this, dropping things everywhere. And the conclusion was what scientists were actually worried about. They're not worried is the greenhouse gas effect real. They're not worried is the Earth warming up. We knew what energy was coming onto the Earth. Where was the energy going? Voila, energy is conserved. Whew. Okay? It was warming up the ocean, but we weren't able to predict the slow ocean mixing and changes with any accuracy. So it's not that greenhouse gases are wrong. Our precision of our models was not like that. It can go on. Are glaciers melting? Is the sea level rising? Short answer, it's yes. Again, satellite data gives the most convincing data. Perturbations in the orbits of satellites with GPS, with radar, actually tell you if the local mass is changing. And so with that, we find that Antarctica, which was supposed to gain in mass, was actually losing in mass during this period of time. The yellow was gaining mass, but only in the first half of the observation period was it gaining in mass. On balance, the whole of Antarctica was losing. It was supposed to be gaining because as the Earth warms, there's more evaporation, more snow in Antarctica, but Antarctica's cold, so it should have accumulated ice mass. Didn't. Surprise. So we missed that. And so I talked about the last warm period, 1 degree warmer. The sea level was 6 to 9 meters higher. That is not a climate model. That's a measurement based on dating seashells that died during that period of time, seashell critters that live between land and ocean all around the world. And so what's a little scary is we used to think that would take many thousands of years to come to this new 6 to 9 meters higher, the UN goal, 6 to 9 meters higher sea level. But now we're frightened that it might take 100 or 200 years, and so this is what's coming on. All right. Now, another final claim, and that is, fossil fuels are very abundant, oil, gas, and especially coal. And so renewable energy will always be less expensive. And isn't it the first priority, especially in developing countries, to grow the GDP? Because you first get them out of poverty, then you worry about what rich countries worry about. And the fact is, they say that renewable energy will remain cheaper for many decades. But that's actually simply factually not true. If you're rural India, where you're not tied to the electrical grid, or sub-Saharan Africa, or Western Alaska, what you find is you have to generate electricity by burning diesel and bunker fuel. And then all of a sudden, renewable energy, wind in Alaska, solar many places else, becomes a low-cost option by fourfold, fivefold. And so this is becoming a reality. In developed countries, wind and solar is actually becoming comparable to fossil fuel. In the United States, the cheapest forms of energy are number 1, natural gas, number 2, wind, number 3, solar, and coal is so far behind that the Trump administration has asked the Department of Energy to say, write a regulation that says, because coal has all this fuel on site, it's energy security, so they should be allowed to charge more money. That's what's happening today. And what's also happening today is you notice the satellite data is most compelling. They want to defund that satellite measurement data. They want to defund the climate measurements, especially the best climate measurements, because they know what they're talking about. The other final thing is that there is a real cost to society. The PM 2.5 is turning out to be far more deadly than we could ever imagine. So let me end the talk by just reminding you of one of my favorite pictures taken on Christmas Eve, 1968, called Earthrise. And the astronaut who took the picture said, "We came all this way to explore the moon. And the most important thing is we've discovered the Earth." So look at that picture. The moon is not a good place to live. The Earth from that vantage point looks great. Even up close, it looks great. Notice everything, black all around. There is nowhere to go. Since 1968, we found the climate is changing. Compelling evidence that it was human activity that's changing this, and we better fix it. Thank you.